Okay, if b squared minus 4ac was equal to 0, then we would see that everything inside the square root becomes 0. So we have the square root of 0. So the quadratic formula in that case so if b squared minus 4ac is equal to 0, then we would have minus b, so we're just working with the quadratic formula here, plus or minus the square root of 0 all over 2a. Well, what's the square root of 0? It's just 0. So b plus or minus the square root of 0, well, that's just b. It doesn't matter whether we add 0 or subtract 0. It's just b, negative b. So we see here that we get only one x-intercept. Okay? And the usual case that we end up with is a number under the square root. We take the number, and then we have minus b plus that number and minus that number. So we get two different roots. So b squared minus 4ac being greater than 0 would be 2 zeros. Okay, let's look at a couple of examples from the textbook. Okay, so number 1, determine the vertex and direction of opening for each quadratic function. Then state the number of zeros. Let's do part B. So in part B we have f of x is equal to negative 4x squared plus 7. So this is in vertex form, it just looks a little bit different. So notice that if I were to rewrite it, usually we have something right here, right? For the x-coordinate of the vertex. It's missing in this case, which means we've only added 0 or subtracted 0, whichever way you want to think about it. So that's really the x-coordinate of the vertex. So the vertex is 0, 7, and the direction of opening, well, the a value here is negative, so that means it opens downwards. So we have a situation here, the vertex is 0, 7, and it opens downwards. So how many zeros are there? Well, there's exactly 1 0. Let's do a question from number 2. Factor each quadratic function to determine the number of zeros. So again, let's do b. So in this case, all we can do is take out a common factor. So 2x is the common factor. Okay, I make silly mistakes easily when I'm factoring, so I always do a quick check and multiply in my head, multiply it back through. 2x times x is 2x squared, good. 2x minus 3 is negative 6x, good. Okay. So it's in factored form now, and the question says, factor each quadratic function to determine the number of zeros. Well, I have a 0 that's 0, and I have a 0 that's 3. So therefore, there are 2 zeros. Number 3, we'll do 3b again. Calculate the value of b squared minus 4ac to determine the number of zeros. So you have to be careful here to make sure that you have a, b, and c lined up. They've done the polynomial in the usual order from highest degree to lowest degree. That's great. Sometimes, though, it might not be given to you in that order. You might have to rearrange. So b squared minus 4ac b squared, so 2 squared minus 4 times 3 times 7. Okay, so I'm going to do 3 times 7 is 21, times 4 is 84. So we have minus 80. So negative 80, that means in the quadratic formula, it would look like minus b plus or minus the square root of negative 80 all over 2a. So the square root of a negative number, that can't exist. That's not a real number. That's not a real solution. So we can't evaluate the expression in the quadratic formula. So because b squared minus 4ac is negative 80, it does not exist. There's no zeros. Okay, so that's the basic idea for how you can apply this knowledge.